Welcome back to Let's Roger That. I'm Gilles. Well, folks, this is episode number 3 of Let's Make a Precision Spindle for my surface grinder. And it's been quite an adventure up till now. It's been difficult, lots of challenges, lots of learning experiences. And of course, I've introduced some re-engineering in this project, so it's made it a little bit more challenging as a result of that. So let's continue making a new spindle. This is the old one, and then at the end, when the spindle is complete, I'll install it in the grinder and do some testing and see what the results are going to be. Stick around. Okay, I've got you zoomed right in. And now it's time to do the deed. So let's do it. So this is going to mean a little bit of polishing, cleaning, measuring several times, all right? It's important to do it as often as possible at this point. There's no room for error. So if you're doing this, take your time. There's no rush, guys. Okay, a little speck of dust here. Make sure my mic is good. All right. See, just that. And I've gone down 1/1000th of an inch already. I'm at 71.5. 671.5. So I've got 1.5 thousandths of an inch to go. This is nice and even, 71.55. We're talking like 5/100ths of an inch here. So of a thousandth of an inch. So I'd rather go, you know, half or 5/10ths of 1/1000th at a time and then not miss my target. So right now I've got 1/1000th of an inch to go. And I'm checking my micrometer every single time. There we go. I'm sweating, but I'm sweating bullets here. This is nerve-wracking for me. Of course, one of the bad things about doing this by hand is that it may not be equal pressure. So probably a good idea if you check the different surfaces, you know, around the circumference. So here I'm right on target at 670. And you know what? I can live with it. 670 and 1/10. Yeah. Now I said 669.7. That would mean I got 3/10ths to go. You know what? I'm gonna call it even. It's done. So that's how nerve-wracking this can be. But it's done now, right? So I'm very happy with that. So that's done. Now I need to turn down the part for the pulley up to where the threads are going to start, because clearly I need that diameter to be turned down so that I can thread these really funky threads. So that's what I'm going to get prepared for. The important stuff just never seems to end in a project like this. So now we've got to turn down the pulley journal, and that's got to go down to 580 thousandths. So that's 91 thousandths from the current diameter. I'm going to take 30 thousandths at a time. Let's do it. Okay, I've got 60 left. I'm going to go 20 thousandths times 3, and we'll give you a better finish. Okay, so this is a good time to take a measurement. The length is nominal, which means it's not critical, but the shaft diameter is important. So let's have a quick look. I know the pulley sits around here. So I thought I had 20 to go. That's exactly what I've got. I'm at, sorry about my arm, I'm at 600 thousandths. So I'll dial in another 20 and that'll be perfect. So here we go, dial that. Leave myself 1 thousandths to play. Here it comes. All right, do a quick little cleanup here. It's not warm. No, it is warm. So I'm going to wait a second here, a couple minutes, and come back to it. Okay, so for the 1,000th time, I've taken measurement of the major outside diameter, which is this here. I've already established that it's 20 threads per inch. And so with this measurement, you go to the machinery's handbook, and okay, so that's 6499, right? So you look for a major diameter 6499, and there's no such thing, and that would be a 2A at 20 threads per inch, which the closest thing is 11/16, but it's simply not there. And the closest measurement would be 21/32 of an inch. So clearly somebody just dreamed up these these threads and went for it. And so it's a custom, not custom thread. And I'm simply gonna have to go with it, simply because the diameter of the bearing is what it is. So that's what I need to set up for. That's what I'm working against. No standards at all. If you're gonna do chamfers, might as well do chamfers. So I'm going to put one at the end of the shaft. And then of course I gotta clean this up anyway. So I'll do that at the same time. Well, as nervous as I was about all the other features, this by far, this threading thing, is scaring the crap out of me. Because I don't do it very often. So, this was my initial pass. I went through the whole setup. And by the way, I watched, and for the 1000th time, a great video on threading by Mark Winquist. So, you know, check out his channel. Totally amazing video on threading. For beginners, it's must watch. So, I'm gonna do that. I've got the original nut on hand to try it as I go. And here we are. Let's do this. My friends, it's time to let her rip. Let's grab some oil and let's do this. Little rag. That nut, put that right here. Won't need this. All right, time to stop getting nervous and do what we need to do. Start with a 5/1000 cut. And let's do this. It's gonna be slow, I'm running on bag gears. This is truly nerve-wracking for me, guys. Like I said, it's not something I do very often, and this is pretty critical, so there is the reason I'm nervous. Up a touch. Let's try again. That's all you can do. Oh my goodness, come on. I think I'm there. I just gotta clean this up a touch. Alright, so I'm gonna give a disengage the bag gear, etc. Clean that up, bring you back. Alright, so I've got the threads done, and this was the most nerve-wracking for me. But in any case, I keep repeating that, don't I? But what I wanted was a real nice loose fit at the front, but snug at the back so that this nut wouldn't come loose like it used to. So to go past this here where I'm going to get preload on the bearing, I've got a, you know, I'm gonna have to use a wrench, and that's gonna be awesome. So with that said, all that's left to do now is to make a keyway and on the mill. So I'm gonna take all this off and do that. Yeah, I'm making the keyway. I forgot to bring you in. Oh, sorry folks. All right, let's continue. I got a few thousands to go yet. Let's see here. Did this one right up to 95. Okay. All right, here we go. All right, folks, this shall be the last pass. And that's it, my friends. We have a keyway. So, gotta clean that up and then go back to the bench, check out everything. Ladies and gentlemen, I present to you the most challenging project I've ever undertaken. Making a spindle for a surface grinder. I'm telling you, that was nerve-wracking, but a whole lot of fun too. Okay, so here are the differences. This is mine, that's the previous one, which I believe might have been homemade as well. Just, you know, so. So here are some of the features. Spindle nose, same thing, except this one is precise and brand new. Fits my spacer perfectly. This is the bearing journal with pre-calculated bearing preload built in, a proper shoulder for the bearing inner race to sit against, and then to be pushed by this to obtain some preload. At the other end, we've got, this is the insert shoulder that goes into the other end. This is a preload shoulder for the bearing inner race, the bearing journal, and if you're interested in understanding precision going machinery handbook, you'll find that for shafts precision, I've selected the M5 category, so which is pretty well, you know, as good as I could do here anyway. A custom made thread pattern that I had to replicate, had no choice, which fits very nicely. A key which is remachined to fit perfectly, and my shaft for the pulley, which is again machined specifically for that. So I am hoping that once I assemble this, I'm going to do that in a few minutes, I'm going to reassemble the surface grinder and do a quick test, and I hope you all cross your fingers for me, and if you're God-fearing, please have a few prayers too. Well, I guess it's time to try that new press on those bearings. So this again, brand new bearings. I didn't take a chance. The other ones are going to get used for something else. So here we go. Going very nicely. Definitely press fit. Now this is a 7/10 of 1/1000 oversized shaft, so gives me what's SKF called a high precision set up for radial preload. So I'm pushing this right against the shoulder, and here I am. Okay, great. Release pressure. And now it'll be time to do bearing number 2. So here we have it. Just so you know, I actually used a square and squared up the whole assembly. And I'll be doing the same thing here again. Just to be sure. Alright, see you on the other side. Well, already I can tell that the grinder is running much more smoothly. I can hardly feel anything other than the same vibration that the motor's getting out. So that's good. So let's give it a few shots here, see what happens. Nice steady stream. That's a nice change. Alright, let's stop it here. Actually, what you see here on this side is what I just ground. Pretty nice finish. Is it perfect, professional? Probably not. But you know what? For a home shop, that's amazing. Now this is the old surface that I was able to make. So big difference for me. So quite pleased with my efforts. Well, I gotta say this. This was a heck of a project. I got the results I wanted out of it. You know, there's some interesting things that came out of this. One, you can do something this complicated even as a beginner. Just be meticulous, take your time. The other thing is I use a 1944 South Bend 13 lathe. If you have one of those lathes, you can do this sort of thing. Of course, it depends on the shape that it is, but it just shows to you that it can be done. So, thanks for watching, folks. Shoot me a comment if you have any comments or questions. Like and subscribe, and see you in the next videos. Take care.